Hello everyone and welcome to this YouTube video, and in this video we're going to talk about the training and testing sets in the section of best practices for machine learning model. And in this video we will divide our data set into training and testing sets, and we'll see some of the solutions for checking if our model is overfitting or underfitting. Okay, and also the important announcement of note here is that the notes of the previous lecture is uploaded, and also the notes of this lecture will be uploaded soon, and please be regular for checking the description box below. Okay, so first of all, let's see the solution, how we can check whether our model is overfitting or underfitting. So first of all, we can plot our hypothesis. Simply we can plot our hypothesis to check whether it is overfitting or underfitting. And what does it mean by plotting our hypothesis? So let's say we have our hypothesis or a predictions. The hypothesis is also called a prediction. This is my prediction, and what I can do is that I can simply plot it. So this is my plotting point, and this is an XY plane and black color here. Okay, this is some of the data points, and what I can do is that I can simply plot this something like this, and if our model is overfitting, what it will do, it will simply something like that. And what is there is that it is good on our training data or our data, but it will fail to generalize to our new data. So that's why this model is not a good model. That I have talked about the problem of overfitting and underfitting in my regularization section, and you will be finding in that end-to-end machine learning course playlist. So here we have, this is the problem of overfitting. Okay, this is the problem of overfitting, and you can think of it as this is not a good model, and this is the solution. This is the solution. We can simply check whether our model is overfitting or underfitting. Okay, but you might be thinking this is only the solution. But if you have a lot of features, let's say an example, you have to predict the price of the house based on the 100 of the features. And you have made a model, and you have to check whether your model is overfitting or underfitting, or it is good to go. For checking that, it has hundreds of features, like the number of bedrooms, then we have a number of floors, number of fans. From this kind of features, etc., to the 100 features, from the given input, this all we have to predict the price of the house. So this is not possible to plot this hypothesis to on our XY plane, because our hypothesis will be something like that: theta 0 x0 plus theta 1 x1 plus theta 2 x2, all the way down to the theta 100 x100. And this is not possible. This is not possible to plot this on XY plane. So another solution would be also, another solution is that we should simply, another solution is that we can divide our data into testing and training sets. And what does it mean? And what does it mean? Simply what we can do, let's say we have a data, and we'll divide our data into testing and a training sets, and then we'll train our model on the training data, and then we'll evaluate our model on the testing data. And this might feel so confusing to you. So for that, now first recapitulation of first, why not we can use the why can't we plot our hypothesis? This is only condition you can go with this solution is that when you have less features and you feel confident to plot on your hypothesis. But if you have lots of features, this will be very difficult to plot on the hypothesis, and we have to go with the solution number 2. And this is the standard way for analyzing the problem of overfitting or underfitting, or checking the model is correct or not. So first of all, let's see the second solution. Let's explore our second solution. Is that here we have to divide our data set, and for dividing a data set, what we can do, we can simply divide our data set into training sets and testing sets. So dividing something like 70 training sets of 70% and the testing set 30%. And what does it mean? Simply that we will divide our data, divide our data into testing and training sets, and typical range for a training set is 70% and the typical range for a testing set is 30%. It simply means that we take training data, we take 70% of the training data from the original data, and we take 30% of the data for testing from the original data. It simply means that. We'll talk about cross-validation set also in our later videos, but the two things for now is the training sets and testing sets. And what is the use of both? Let's see the workflow for a basic workflow or a procedure for a linear regression training and testing cycles. So before going on to that, how we can denote this? We can denote M is the number of training examples, number of training examples. Okay, number of training examples, and here hashtag is also known as number. And here M is the number for training examples, but if we have two kinds of data, training data and testing data, so we can denote M train for training and M test for testing. Okay, this is very clear, the notations are very clear to you. M train for testing and M test for testing sets, and this would be very clear to you. Okay, now a basic workflow for a cycle for a machine for a linear regression model. So the first thing is that what is the meaning of training? Training, yeah, no. What is the meaning of training? It simply means we will train our model with a training set and learn the parameters theta. And training simply means this workflow. First we have our hypothesis. Okay, then we use our cost function j of theta, which gives an error that how our model is. And then after we optimize using a gradient descent. And here we learn the parameter, which is the best parameter that fits this model. Okay, this is the basic workflow for your training. And you can simply think of it as, let's say we have trained the model of a linear regression model. So the second thing is that then we will compute cost function or mean squared error for testing set. So how do we, so we have trained the model here, we have trained the model with this data. So if we give a new data, this test set will be the new data for the particular model. This test set would be the new data, okay, new data for a machine, for that model. Okay, so here we will take this parameter, and we'll compute the cost function. We have learned the parameter here, that we have good parameter. Okay, by optimizing that from the gradient descent, we got the parameter. Okay, now what we can do, we can simply 1/2 M test, because we are checking the cost of a test, and 1/2 test I equals to 1 to the all the way down to M test h of x I minus yi squared. Okay, and then if we do this all this kind of, we will compute our cost function. If we get something like a good thing, that is good to go. But if we get a bad thing, it can cause the overfitting, I know. And if we saw the underfitting type, we can think of it as from here, because if we get underfitting, it simply means we will get in this cost function, and we will fix that underfitting. And here, if we get a very good amount of results from, we get a good amount of the, we get a less error, so it is good to go. But if we get something like a bad thing, or it's generalized well on the training data, but it fails to generalize well on our testing data, so that's why this is not a good model to perform. Okay, so that's why we don't use, so we can understand if our model is underfitting, overfitting, or it is good to go. In this case, if it is unable to generalize well on the testing set, then it is overfitting. If it's able to generalize well on our testing set, then it is good to go. Okay, this is the notes you will be getting in the description box below. So these all are the notes that you will be getting. And the training and testing cycle for logistic regression is also the same for that. For logistic regression also as kind of the similar to the linear regression. First we'll train the model with first we'll take out a h of x, then we'll take out the cost function and then optimize the parameter, which is a theta, and we have a good parameter theta. And what we'll do then, we'll compute cost function, or for our testing, say we have our parameter theta. It simply means we have learned a parameter, and this model generalizes well on our training set. And we take that parameter and pull up into j of theta for our test set. Only that. Okay, this is very pretty much clear to you, and this is all done. Okay, so I think this would be very much clear to you about training, testing sets, and also in the next video or in the future video I will be bringing up the cross validation also. And if you have any kind of problem, please comment down below. And now it's time for the implementation part for our training. How do we split our data into training and testing sets? So let's get into the training or implementation part. So I'm on my Jupyter notebook named training and testing sets. So first of all, let's import the libraries. Import numpy as np, and then we'll import pandas. Import pandas as pd, yeah. Then there is a library called scikit-learn, which will help us to import the train test split, which will help us in splitting our data set into training and testing sets. Okay, so first of all, let's import from sklearn model selection sklearn.model selection, and what we can do, we can import train, test, and split. Okay, and just run this. Now what is this? Something kind of the warning, so let's leave that and let's run it again. Okay, then we have from sklearn. Now let's see some of the data. So first of all, let's import the data, which is an iris data set, which is a very famous data set that is used for classifications. So we will see that in our project also. Okay, from sklearn the data sets. So it's very simple. So from sklearn we have in sklearn there are a lot of libraries that has some kind of the data set, like the iris, load Boston, breast cancer, diabetes, digits, files, iris. You can do this. And what I can do, I can instantiate this as iris equals to load iris, and okay, instantiate it, done. And if I print out iris, it will in array format, but we don't want this in array format, so we will convert into data frame. So we have a data variable pd.dataframe, and this data frame, what we can do, we can simply pass our iris which we have instantiated, iris.data, and yeah. Okay, and then what we can do, we can simply do this, yeah, something like that. It's good to go. But here our column name is not here, and the target variable which we have to protect. So here, let's say let's make the columns. So the data.columns, which is not then iris dot feature names. So I think data will be sepal length, sepal width, petal length, and petal width. We'll take a look at this data set in our project of classification. So I'm not going to explore this data set just now. We will more excited for seeing this kind of the classification problem. And then what we can do, there is a missing called a target variable which we have to predict on the basis of these kind of features. So what we can do, data, we will make a column spacious and equals to iris iris that we have instantiated dot target. Okay, now I think there is the large. There is a species also which is given in a 0 or 1, whether it is Setosa, Verzanica, and okay, there's Setosa, Verzanica, and one more I am not remembering why. I don't know why. I'm just forget about the name. Verzanica, Setosa. Okay, then we have now. The main thing is that we can simply divide the data set into training test set and the testing set. For that, we'll make 4 variables: training, testing, y test, y training, and y testing. So for that, x train, I will explain just in a second. X test, y train, right, and y test. Train, test, and split. Then what I can do is that I can simply pass x comma y, but x comma y is not made, so let's make that x comma y. So here x would be the data we will drop what we'll drop, we will drop something like a species, because we don't want a species on x. Okay, so here we have species equals to x. Okay, now in y we have to take a species as a y, so data species. Okay, oops, oh sorry, we have to specify the axis equals to 1. Okay, so we have now kind of testing. So let me do this. You can able to see. So x comma y, test size that I have just given out the 30% of the total data. So test SCE equals to 0.3, and then we have random state, something called a random state. And what does it help us? It help us first of all, it helps us so that our testing do not change further if we do that. So it's a good practice to doesn't change or shuffles our data. Equals to 3. Oops. Testing size, oh, TSIZ. See. Okay. So here we are good to go, and we have divide our data into training and testing sets, and here x train and x test, y train and y test, we have divided into 4 variables, and we are good to go. And I think that's it for this video. I'll be bringing up this data set in a process classification, and also the digital recognition project will be upcoming soon, so be sure to press the notification bell. And also, if you're new to the channel, be sure to subscribe this YouTube channel so that you can get videos every day and learn new things daily. So that's it for this video. I'll be catching up you in the next video. Till then, bye bye.